I want to return here to the CD program that I wrote earlier. That's the one that maintains a list of the CDs in my collection. So this is the Objects2 project. Let me just run it. I've made some modifications in this project, and specifically to save and load the collection to and from disk. Let me show you the program first. So these are the CDs in the list. There are 10 there, and it just shows the name, the artist, the price, and the record label. If I free the objects, remember free calls the destructor to destroy the objects, and now I show them, they all show that they've got nil value. I can create them again, show them, they're back to the data they originally had, free them, show them, nil. Okay, let me create them, show them. Now I'm going to save them to disk. That's here. Before I load them, I set them back to nil, so you can verify that the load procedure really does something, really does initialize them again. So this time I'm loading my previously saved data from disk, and now when I show them, and sure enough, they've been reinitialized with the data that's been loaded. But how do you save and load objects? It's not as simple as saving and loading records. In fact, if you really wanted to do it in a more powerful way, you would use a technique called serialization, whereby each class defines some way for the objects to save their data, their own data, as bytes. That's little chunks of data into a stream object. And you can then read and write streams of objects, but that's quite an advanced subject, and it's too complicated, really, for this stage in our course. So I've got a much simpler way of doing this. Since the CD object is very similar to a CD record, I can define a record with the same data types and the same fields. And now when I save data, this is the procedure that executes. So you can see that I've got a rec file variable, which is a file of CD rec. That's the records rather than the objects. And here I go through the normal assign file rewrite that I've talked about before, and I set up a for loop, and this for loop just goes through the array of objects, and it assigns the data from each field into a compatible record. And it's the records which are then written in the normal way to a typed file, and when I read them back in, I just do the reverse. So load, button click, opens the file, assign, reset, and then it has a while loop which reads to the end of the file, and it initializes one record at a time, and it's the data from the record that is assigned to the object. And each object is then just added back to the array that I maintain in the program. Now there's one other thing that's worth mentioning. When I clicked free obs, this calls the free obs method that I've written. Let me just find that. Right, here it is. So what this does is, for each object in the array, it frees it. It calls the method that calls the destructor to reclaim the memory for that object, but I then explicitly set it to nil. Nil is a special value. Nil can be assigned to show that the object does not exist, but nil will not automatically be assigned just by destroying it. So what I'm doing is I am putting nil values into each slot of the array which previously contained an object. Now, why do I do that? Well, when I call show all, for example, I am able to check if the CD object, if the object I'm looking for at each array index is nil. I can see if it contains the value nil. If it does, then I can display nil, the text nil, rather than trying to display some data from an object that doesn't exist. And I use this nil test in other places too. When I free the objects, I can check if the object at each index item is not nil, and only if it is not nil do I attempt to free it. Or up here, when I create the objects, I again check if each item at the array is nil, and only if it is nil do I create a new object and assign it to that position in the array. So nil is a useful value. By assigning nil instead of that object, you have a check as to whether or not the object is there for you to access.